All right. So now we're on to Chapter 14, Security Command Center. Be aware that because I don't have the organization activated, we're not going to get as deep. We're going to get deep, though. So Security Command Center is Google Cloud's comprehensive security management platform. It provides organizations with centralized visibility into the security posture across their Google Cloud resources. Introduced in 2018, SEC enables security teams to monitor security controls, detect threats, and respond to security incidents through automated workflows and integrations. This will explore SEC's core components, capabilities, and implementation strategies to help you effectively secure your Google Cloud environment. So here's an overview. Security Command Center serves as a centralized dashboard for monitoring and managing security across your Google Cloud assets. It aggregates security findings from various Google Cloud services and third-party security tools, providing a unified view of your security posture. So let's go to Command Center in the console. So you see, you'd have to select the project here. We'll select this one. And see, I told you we had to be a part of an organization to get this to use, right? So if you click here, well, we can see if we can enable this. But we'll provide this information in the chat. And then from here, this is for a higher tier paying customer. That's why they want it, right? And you could choose your desired tier, standard or premium, and then enable the product, as you can see here. You can also do this from the Cloud CLI with the following command. gcloud services enable securitycenter.googleapis.com and then the project ID. Okay. So some key features. There's centralized visibility and control. Security Command Center provides a comprehensive inventory of cloud assets across multiple Google Cloud services, including App Engine applications, BigQuery datasets, Cloud SQL instances, cloud storage buckets, Google Compute instances, identity and access management policies, and Google Kubernetes Engine clusters. For large enterprises, this visibility is critical to understanding the total number of projects in your environment, resources deployed across in projects, the location of sensitive data, and changes to accounts, services, and resources. SEC provides access to assets and findings through its REST API, facilitating integration with existing security tools and systems. The platform tracks asset history, allowing you to understand precisely what changed in your environment and prioritize response efforts. One of the most valuable assets of SEC is its notification system. You can receive alerts about new findings or updates to existing ones typically within 6 to 12 minutes, ensuring timely awareness of security issues. Misconfiguration detection and remediation. Security Center includes built-in services that identify security misconfigurations and vulnerabilities, like 1, Security Health Analytics, SHA. This identifies security misconfigurations of Google Cloud assets and provides actionable recommendations for resolution. 2, Web Security Scanner, WSS. This automatically detects and scans web applications running in Google Cloud for vulnerabilities, helping to identify security flaws before they impact production environments. Then you have compliance and monitoring. The premium tier of Security Command Center, let's see if we can find. No. Now, it helps identify compliance violations in Google Cloud assets and provides actionable recommendations for remediation. It generates compliance reports to ensure resources meet regulatory requirements across frameworks like CIS, PCI DSS, NIST 853, and more. So the threat detection services are included, and these have several detection capabilities. 1, Event Threat Detection, ETD. This analyzes Google Cloud logs at scale to identify potential security threats. Container Threat Detection, KTD. This monitors container environments for suspicious activities and potential attacks. And then Virtual Machine Threat Detection. This identifies threats targeting compute engine instances. These capabilities leverage Google's threat intelligence and third-party integrations like Palo Alto Networks to protect your environment from high-risk threats and allow you to respond using Cloud Pub Sub functions to reduce resolution time. So let's show you how can we do the core services to give you a good idea. So let's go to the Security Center command page, which I think we're at. You select your organizations, right, or your project if it was involved, and you click on settings, which would be here. Then you go to the integrated services tab. which I don't have access to. And then you go for your requested service, right? From this, it's going to be the security health analytics or the web security scanner. You would manage the settings and enable or disable it, much like the other APIs, as needed. But please remember, some services are only available with the premium tier. Then you have cloud asset inventory. All right, let's go here. Wow, it won't even let me go here. This is fantastic. All right, so let's try it here. Cloud asset inventory. Let's try and get the overview here. All right. So Cloud Asset Inventory provides comprehensive visibility into all your assets in the Google Cloud organization. You can search for assets by resource type, project location. You can view all IAM policies across your organization, and you can track asset history and changes over time. Access to Cloud Asset Inventory is role-based, with security operations teams typically having organization-level access, while project teams have project-level access. So working with Cloud Asset Inventory, one, you can list assets, right? You can list all the Google Cloud resources within your organization. This is compute engine instances, projects, BigQuery datasets, and cloud storage buckets. And you can filter your assets. So when organizations have many assets, SEC provides filtering capabilities similar to SQL with where clauses, the capital WHERE. And you can filter assets by API identifiers, JSON arrays and objects, partial string matches within objects, or JSON object subfields. So filters must use comparison operators with the appropriate data types. And I'll give you an example here, right? So here, see strings, full equality, partial string match with the colon, right? Or you could do numbers, inequalities, so less than, greater than, less than or equal to, greater than or equal to, or equality. Or you can do booleans, right? Which are kind of an either or situation. So equality going there. And then you have time-based asset analysis, right? SCC enables you to view a snapshot of organizational assets at a specific point in time, down to the millisecond. It also lets you identify assets that change state after a certain time. And it lets you compare assets between 2 points in time to detect changes, removals, or additions. So you can also export assets to BigQuery. You can export these for advanced analysis without custom scripting. This is particularly valuable for identifying IAM policies that violate organizational policies. Then you can detect security misconfigurations and vulnerabilities. Security Command Center offers 4 primary vulnerability detection services. One we already talked about, security health analytics. I'll get you documentation here. Okay. All right, SHA provides built-in detectors that identify misconfigurations and scan your Google Cloud organization for known vulnerabilities against compliance benchmarks like CIS, PCI DSS, NIST 853, ISO 27001, and OWASP Top 10. SHA begins scanning approximately 1 hour after Security Command Center is activated and operates in 3 basic modes, right? 1, batch mode. This runs twice daily for all enrolled organizations and satisfies SLOs, or service level objectives. Resources and policy changes are processed in the next batch scan. 2, real-time mode. When Cloud Asset Inventory reports a configuration change, supported detectors begin scanning immediately, and findings are sent to Security Command Center as soon as they're available. And 3, mixed mode. Some asset changes trigger real-time scans when others are captured in batch scans. This provides a balance between immediate detection and comprehensive coverage. 2, next you have a rapid vulnerability detection, RVD. RVD identifies potential vulnerabilities like weak credentials, incomplete software installations, and other security weaknesses. The service automatically discovers network endpoints, protocols, open ports, network services, and installed packages, and serves as an early warning system for vulnerabilities that require immediate attention. Then there's Web Security Scanner. WSS scans App Engine, GKE, and Compute Engine applications for security flaws by crawling public URLs and IP addresses, following links within the scope of your application, testing user inputs and event handlers, and identifying common vulnerabilities like SQL injection and cross-site scripting. WSS supports App Engine standard and flexible environments, Google Compute Engine instances, and GKE resources. The scanner offers two types of scans. Managed scans. These automatically detect and scan public web endpoints once a week, use get-only queries without authentication, run independently of project-level scans, and provide centralized vulnerability monitoring without project team involvement. Then there's custom scans. These provide detailed information on application vulnerabilities. They can also be configured for specific testing needs, and they support authentication for testing secured applications. So the best practices for web security scanner are the following, right? Web security scanner performs user-like actions, like filling forms, clicking buttons that could potentially alter data. You should also test in a separate environment before scanning production resources. Then when you create tests with limited access, make sure you do this so that it doesn't have access to sensitive data. Also, use the no-clicks CSS class to prevent activation of specific user interface actions. So then you want to back up data before scanning. You want to configure URL exclusion patterns to limit scan scope, and you want to consider what's within and beyond the intended scan scope. Then you have VM manager vulnerabilities. Let's get you some documentation on this. All right, we'll get this here. Okay. Okay, so these are vulnerability reports. That'll be in the chat as well. So VM Manager is a suite of tools for managing operating systems on Windows and Linux virtual machines running on Compute Engine. As a paid service, it enables organization-wide patch management, project-level patch management, and vulnerability reporting for installed operating system packages, including common vulnerabilities and exposures, CVEs. Vulnerability reports in VM Manager are generated within minutes of configuration changes for most vulnerabilities. And also within about 3 to 4 hours of publications for new CVEs. This provides a graphical interface to visualize your findings. Then you have threat detection. Google Cloud offers several threat detection capabilities that Command Center handles as a priority. Get you documentation. All right. All right. So ETD, this is event threat detection. This is included in the SCC premium tier and continuously monitors your Google Cloud environment for threats. It analyzes cloud logging and Google Workspace log streams. It matches events to known indicators of compromise. It detects deviations from historically observed behavior and regularly adds new detectors for emerging threats. ETD can detect various threats, including unsafe IAM changes. For instance, it identifies when external group members are granted sensitive roles by examining cloud audit logs. And then the findings are categorized by severity. So there's high severity, where sensitive roles are at the organization level, and a medium severity, where sensitive roles at lower levels in the resource hierarchy, likely in the folder or the project. But there's log requirements for ETD. So admin activity logs are automatically consumed by ETD without configuration. Additionally, external logs will improve ETD performance, but may incur additional costs. Also, Google Workspace audit logs enable detection of threats across your workspace environment. Then you have container threat detection. We'll get you some documentation on that. Okay. All right. So container threat detection provides threat detection for Google Kubernetes Engine platforms by analyzing kernel-level behavior in container environments. It can detect added binary executions, so binaries not part of the original container image that may indicate malware or exploitation tools. It can detect added library loaded, So libraries that are not part of the original container image, which attackers might use to bypass code execution protections. Malicious script executions, so machine learning models that identify potentially malicious bash scripts, and reverse shell attacks. So it'll process streamed redirection to remote connected sockets, allowing attackers to control compromised workloads. Then you have VM threat detection. We'll get you some documentation there. Okay. Which I might have already included, but there we go. Here's a good overview. We'll get that in the chat there. So this premium SEC service detects threats at the hypervisor level with a focus on identifying cryptocurrency mining software. The service executes from the hypervisor into guest VMs without interrupting operations. It analyzes running software, CPU usage, memory hashes, and machine code. It also operates outside guest VMs and doesn't require guest agents or specific configurations. And it's immune to tampering due to hardware encryption of memory. So VM threat detection can identify various cryptocurrency mining activities, like cryptocurrency mining hash match. So this will match memory hashes against known mining software. Cryptocurrency mining Yara rule, which identifies memory patterns used by mining software. And cryptocurrency mining combined detection, which aggregates multiple findings within a 1 hour period. And then you have anomaly detection. Anomaly detection identifies unusual behavior between in your Google Cloud environment, such as potential credential leaks, cryptocurrency mining, and this feature activates immediately and is available in both premium and standard CCC versions. And we'll see if we can get you some detection, some documentation. Okay. All right, we'll add this here. Then you have continuous compliance monitoring. In regulated environments, compliance with industry standards and regulations is paramount. Security Command Center supports continuous compliance monitoring by identifying violations of Google Cloud assets. It'll provide actionable remediation recommendations, and it will enable compliance report generation and exports. And then there's supported compliance frameworks. And this is why SEC is important. The base frameworks that you should know and that it does work with are CIS benchmarks, though many will become deprecated, PCI DSS, NIST 853, ISO 27001, and OWASP Top 10. It's important to note that these mappings are provided for checking violations, but are not intended as the foundation for audits, certifications, or compliance reports. Then you can export or manage your findings, right? Well, you can do both, right? So Security Command Center provides multiple options for exporting findings. We'll go over here and see if we can get here. So you can download current historical findings and assets in JSON or JSON-L format via one-time exports using the Google Cloud Console. And this can be done to upload this to a Google storage bucket, or you can download this to your local machine. And you can do continuous exports. So for ongoing monitoring, you can automate the export process. So you can do this with PubSub. So this will immediately export new findings to the PubSub topics in near real time. And you can configure this using the API or CLI. And then you can filter this by category, by source, by asset type, security marks, severity, state, and other variables. And you can set up to 500 continuous exports. Then you could do BigQuery exports. By exporting these findings to BigQuery, you can put these in the tables as they're created. And this will integrate with your existing workflows. It'll perform custom analysis, and you can export this at the organization, folder, or project levels. And you can automate your findings requests. One of Command Center's most powerful capabilities is automating responses to security findings. You can set up workflows based on SEC alerts and findings. You can trigger automated remediation actions, and you can integrate with existing security tools and processes. For example, you might configure an automate response that does 1, detects a public cloud storage bucket, 2, automatically changes bucket permissions to private, 3, notifies the security team, and 4, logs the actions in your SIEM system, SIEM. So here's a basic implementation guide, which we've already gone over a little bit throughout this. So if you go to the Cloud Console, you're at security, right, which is the hamburger menu is down here. And then you go to Security Command Center, which we're already on, but I want to see if I can find it for you here. Well, security, yeah, overview. And then if you'd have to set up your organizations, make sure it's set up, choose standard or premium, and then enable it. All right. And then you should be able to go through each one of these threats, vulnerabilities, assets, findings, sources, all of this, right? And after enabling SEC, you can configure component sources like security health analytics, which can configure scan frequency like batch or real time. You can do web security scanner. So this will be for managed scans for no additional configuration, which will need no additional configuration. But for custom scans, you need to define the scan targets and authentication. And you can do container threat detection, which would be for specific GKE clusters. And you can do event threat detection, which would be able to be configured for logging requirements, right? Well, you would need to configure the logging requirements. And you set up the notifications, right? So under, let's see. Let's see. What we do? Advisory notifications, settings, opt-in, sensitive. So these would be automated ones. Uh, mm, so I guess so you'd have to have this set up and be able to notify this, but you would then be able to configure this to notify you via email, SMS, PagerDuty, or PubSub. And you'd set your filtering criteria for the type of notifications. All right, so I think we've gone over a good amount of what this does. And you can also set up the security notifications in the CLI. That's one other thing I forgot to tell you. Um, you can also use the following. gcloud, gcloud SEC notifications, create a notification ID, organization ID, description, project ID, and topic name, filter expression. All right. And you could replace that with your specific values. And then you could do the PubSub exports, which I was talking about that's at near real time. This would be over here. Once you're in, from here, once you have this configured, you'd be able to configure this with the PubSub topic, figure for export frequency, and then you'd save it. And show you the command. All right. gcloud sees SEC notifications, create notification ID, organization ID, the description, the PubSub topic, and the filter in the categories and severity, and you would be good to go. All right. And you could set it up with BigQuery. So you could set this up to export to BigQuery as a data set and then configure the export frequency. But that would be also similarly done for your exports in your posture management, your threats, and the security command center. All right. So here's some best practices. Remember, effective configuration. Start with the premium tier for comprehensive protection. Enable all security services appropriate for your environment. Configure real-time scanning for critical assets. Set appropriate notification thresholds to avoid alert fatigue. And leverage automation to streamline responses to common findings. Right? Then regularly monitor. That means review the SEC dashboard daily for high severity findings. Perform weekly reviews for medium severity findings, and then conduct monthly compliance reviews against relevant frameworks. And finally, remember to track findings to resolution metrics to measure security improvement. Then integrate this with your security operations, right? Export the findings to your SIM for correlation with other security data. Integrate it with your ticketing systems to track for remediation. remediation. Then include SCC data in security reporting for leadership visibility. And finally, automate your common remediation tasks to reduce response time. All right. And you should be good to go forward from here. So remember that Security Command Center provides a comprehensive security management platform for Google Cloud environments. By centralizing visibility, detecting misconfigurations, monitoring compliance, and identifying threats, SEC enables security teams to maintain a strong security posture even as cloud environments grow in complexity. The combination of built-in services like security health analytics, web security scanner, and threat detection, along with integration options through APIs and export mechanisms, makes SEC a powerful foundation for cloud security operations. By implementing SEC with appropriate configuration, regular monitoring, and thoughtful integration with existing security processes, organizations can significantly enhance their cloud security posture and reduce the risk of breaches and compliance violations. Thank you for joining me. Next up, we're going to cover container security. Until then, have a good day.